About multiplying radicals. Let's get started. So first thing we want to take a look at is the big rule. This is something you've seen in simplifying radicals, and this rule is that if we have the square root of a times the square root of b, then we get the square root of a b. You've seen this in simplifying radicals. Things like if we have the square root of 20, we could split that up into the square root of 4 times the square root of 5. But we know that the square root of 4 is 2, so we can call this 2 root 5. So this is the big rule. We can use it the other way as well. For instance, what do I do if I'm multiplying the square root of 2 times the square root of 7? Well, this rule says that I can combine those. I can make this the square root of 14, and that is my answer. Square root of 14 cannot be simplified anymore. Or if I have, let's say, the square root of 15 times the square root of 2, what would that be? Go ahead and answer it. If you need to pause, you can. That would be the square root of 30. So let's take a look at what would be the full process for doing one of these problems. The process, it's pretty simple. It's going to be simplify each factor, multiply the factors, and simplify the product if possible. So simplify, multiply, simplify. Those are the rules you're going to remember. Let's take a look at a couple examples. First one, if I have the square root of 5 times the square root of 35. Let's go ahead and first simplify that. Now, in order to figure out if we can simplify that, let's get the prime factorization of each of those. Now, 5 is already prime, but what is the prime factorization of 35? It's 5 times 7. Now, neither of those have any double factors. Neither of those we can take the square root of. So we'll go ahead and combine. We can't simplify. That was our first step. Simplify, multiply, simplify. We can't simplify, so let's multiply. We're going to get the square root of 5 times 7. And now that we've multiplied them together, you see we're going to be able to simplify. Square root of 5 times 5 would just be 5. That simplifies to just 5. It's like the square root of 25. So we have 5 root 7. Let's try another one. Let's try the square root of 50 times the square root of 32. Why don't you go ahead and pause the video and try this one. Simplify first, then multiply together, then see if you can simplify any more. All right, hopefully you've worked this one through. Let's see what the answer is. Well, what goes into 50? How could I break up 50? Well, square root of 50 would be the square root of 25 times the square root of 2, right? So I could really just call that the square root of 25 times the square root of 2. That would be 5 root 2, right? So really, all I have here is 5 root 2. I'm going to cross that out and put 5 root 2 times what perfect square goes into 32? Well, 16 does. So this would be the square root of 16 times the square root of 2, which is 4 root 2. So right now I have 5 root 2 times 4 root 2. How are we going to multiply that? Well, multiply the coefficients, 20. And what is root 2 times root 2? Well, it would be root 4. Hey, hopefully you noticed something here. What is the root of 4? The root of 4 is just 2. So really this is 20 times 2, or just 40, because we can change this to just 2. And there's our answer. Let's take a look at one more of these. This one's already going to have coefficients at the beginning. If I have negative 2 square root of 27 times 5 square root of 50. Ooh, 50, we've already used that one. That's nice. So let's go ahead and simplify first. Really, over here, we have negative 2 times the square root of, what would be the prime factorization here? It would be 3 times 3 times 3. And 5 times the square root, what would be the prime factorization here? Well, it would be 2 times 5 times 5. This one's going to be able to simplify, and this one's going to be able to simplify. We have negative 2, and we can take the square root of those two and leave the third one on the inside. So we have negative 2 times 3 times the square root of 3. And over here, these 5s are a pair, so the square root of those is going to be 5. So we have times 5 from our outside and times 5 from our square root, and we're left with the square root of 2. So let's multiply our coefficients and multiply our square roots. Well, what's negative 2 times 3 times 5 times 5? Really, we're ending up with like negative 2 times 5 would be negative 10. Negative 10 times 15 would be negative 150. And we're going to be left with the square root of 6 on the inside. Can I simplify square root of 6? Nope, so we're done. All right, but what if we get variables involved? Let's go ahead and try a couple examples where there are variables. First one we're going to do is the square root of 6ab times the square root of 2bc. Well, let's go ahead and make sure we have our prime factorizations. Now, prime factorizations don't apply as much to variables, but with numbers, they're really important. So we have the square root. What's the prime factorization of 6? 2 times 3, ab, times the square root of 2bc equals the square root of 2 times 2 times 3 times a times b times b times c. Whew, that was a long one. All right, so the square root, let's find our pairs. Oh, that's going to simplify. We're going to have a 2 on the outside. That's going to simplify. We're going to have a b on the outside. And we're going to end up with 2b square root of 3ac. Let's try another one. This one's going to be a little bit longer. What if we have some cube roots? Let's try this one. Let's say I have the cube root of 4x squared y squared z times the cube root of 32 x y. All right, let's go ahead and find our prime factorizations. There's not too much to break up here. I'm going to go ahead and do this one below. So we have the cube root of 2 times 2 times x squared y squared z. And the cube root of, let's see, 32 would be 2 times 2 times 2 times 2 times 2 xy. Well, there's no perfect cubes in there except I see this one. The cube root of 8 really is what it is. So you have the cube root of 2 times 2 times x squared y squared z times 2 cube root of 2 times 2 times xy. That's going to be 2 cube root, and let's get all our 2's. We have 4 of them. 2 times 2 times 2 times 2. X cubed, y cubed, z. Aha, I see another few pairs we can get out here. There's a triple, there's a triple, and there's a triple. So we're going to have 4, because we have 2, and then our other 2 that we're getting from here. 4, x, y, and then what's left on the inside? The cube root of 2z. I hope this video has been helpful and that you are now an expert at multiplying radicals.